Hello and welcome to the last of our webinars today. Had a long line of webinars over the last month, and we're happy to have you calling in or signing in from wherever you are around the world. Today we're going to have a look at the photovoltaic hybrid system. My name's Daniel.
I'm Fabian.
Fabian, great to have you here and great to have you all from wherever you are around the world. So we're going to have a look at the system in a little bit more detail. Fabian, you've been involved, or you actually developed this system, designed and developed the system. Maybe you could just tell us a couple of little things about the system, like for instance, who would be the target group for doing training on this system?
Okay, the hybrid system, or the meaning of hybrid is that you feed your consumers with different sources. So in this system, you have once the PV, a battery, and a grid. Grid is optional here, and you can use it as a UPS power supply.
Uninterrupted power supply.
Yes, yep. And everywhere where you have blackouts or the need of a UPS system, there is the focus of this training system.
Okay.
So everyone who installing such a system, yes, is the customer or can be the customer of the system.
Okay, so it'd be like the electricians that need to install the actual hardware into a building or some sort of system that would use this.
Yeah, installing and planning a system. So, but your consumers, you would like to feed your consumer every time, and you have to calculate the size of the battery of the PV system. These are all topics that you need if you're planning and building a system.
I guess it must be quite different for if this is something normally, if someone's used to running grid systems, then understanding how the mechanisms are switched over from batteries, that's quite important for an electrician to know, because then you've got different points that are going to be live at different times and how that's all controlled. So that's something you would learn here, for example. Yes. Okay. What sort of situations would you expect to see this in? Is this something like buildings or houses, or is it more industrial? How would you expect to see this in real life?
In real life, you can find it in households, also in bigger housing like a hospital. You can find such a system, but also farmers can have a need of that, because if you have plants somewhere outside and you need have fontaines there to run the pumps, you can use such a system. So with the PV and the battery, you can also run the system in the night. So there are different areas where you can use it.
Okay. And it's, I think this is something literally all around the world as well. I mean, we've had this, I'm originally from Australia, and there's a lot of people, because there's not many people have, might cost a lot of money to have the mains or the grid sent out there. So a lot of people are using solar panels, but then eventually can get the grid. But I guess also we travel a lot for our work. So you see this in a lot of developing countries where students might be working in a laboratory and all of a sudden there's blackouts. And so systems like this could actually help in those countries as well.
Of course. So to run your consumers like a fridge or a pump.
Things that need to be going all the time.
All the time. So.
Okay, great. All right, well, we've got people are putting in questions and here we go, Q&A. Good morning. We have a Q&A here. So Fabian is the technical expert for the system. If you do have any questions, we'll be here after. We're going to show a quick video now. So I think the video does explain it quite well. Our colleague Marcella, if Marcella's watching, big hello, good morning to you. So she did this video. But if you have any questions, we'll be here after and we'll be able to answer those questions for you. So it's about a 10-minute video, I think. So have a look and speak to you soon.
Hello, I'm standing here in front of the Lucas-Nuelle training equipment in photovoltaic hybrid systems. Hybrid means that the system can be powered by different sources. These systems are conceived to ensure power supply in areas where this supply is critical. Students must now prepare to be able to operate, design, and install such systems. I will start by briefly describing the components of the system. We start here with the connection point to the grid, accompanied by a smart meter which transmits information to the SCADA. And here we have a power switch which allowed us to connect or disconnect the grid easily. In the middle, we have the most important element of the system, the battery-powered inverter. This device, apart of operating as an inverter with battery management, also has a solar charge controller with MPP, and also an AC charge controller, so the battery can be recharged when the capacity level is too low, for example, at night. This device also has a measurement module which collects data and sends it to the SCADA. On the right side of the inverter, we will find two types of loads, which will help us to investigate the variations on the system depending on consumption. In these systems, we have two types of different generators. The first one is the photovoltaic system, which is built up with this DC control power supply, together with the software, the solar panel emulator, which will help us to set different irradiance values. On the other hand, we could also load a solar profile to emulate the behavior of the system during a specific period of time. Apart from the photovoltaic system, it is also possible to connect the small wind power generator. If we do so, we can expand the system to form a small microgrid. And here, on the bottom part of the system, we find our battery. We will use this measurement device to display important values like voltage, current, and power. Now, I want to show you the SCADA interface that will allow us to observe everything that is happening in the system. As you can see, the measurement values at the different points of the hybrid system can be monitored in real time, which makes for the students easy to understand how the energy flow and the different types of operation works. Along with the system, you will find an interactive course that can be installed on a PC. The multimedia platform used here is called LabSoft, and it allows you to display theory, setups, practical exercises, and perform real-time evaluation in a very user-friendly way. Additionally, each course has different virtual instruments that will make the configuration of devices and data acquisition easier. We have prepared the wiring of the system before, but the wiring is always available in our course. Now I'm going to connect the battery to the system, and you can see that the system directly starts working, and the load is being powered by the battery. Now I will connect the grid. Other operation modes are possible, even maximizing the autarky. Now I would like to show you the second mode. Using the integrated charge controller with MPPT, we can connect a photovoltaic facility to recharge the battery. This configuration corresponds to an island operating mode. Using the solar panel emulator that I have mentioned before, we can set a fixed value for the irradiance, or we can load any solar profile to emulate the irradiance curve for any time of period. I will set a fixed value here so you can observe better what is happening in every phase. If the solar irradiance is enough, the photovoltaic system starts to deliver power. If the solar irradiance is enough, the photovoltaic system starts to deliver power. Depending on the amount of power produced, it will be distributed to supply the load and to recharge the battery. If too much power is produced, the system cannot process it, and consequently, depending on the battery charge status and the load, the working point will not be at its maximum, but instead it will be at a reduced value. If the value of solar radiation is very small, then the load will be supplied together by the battery and the photovoltaic system. Now I would like to explain you the next operation mode, which includes the connection of the small wind turbine. For doing this, I will disconnect the photovoltaic system so we can perceive the differences that are happening on the system. For doing this, we will need to use the virtual instrument Wind Control Center, which can be found in our labs, of course. I will set control by wind and select a value of 8 meters per second. Okay, now I will enable the instrument. First, starting the recording, so I am able to see some parameters here. And when I start, we can see on this diagram how the voltage is rising. But this is not all. We can also show some other parameters which are important for the system. For example, the current and the active power. So right now, our system is being supplied by a second generator, in this case the wind turbine. The loads are being supplied together by the wind turbine and the battery. Further experiments are possible, of course, and then you can find them on our labs, of course. I will stop the wind turbine now. There are other possibilities. For example, we could connect a solar pump to our system as an alternative generator. Additionally, we can connect the real wind turbine or the photovoltaic module. This new photovoltaic hybrid system will become part of our power engineering lab, which you can see on the background. Important parts of this lab are wind power plant, microgrid, smart grid, energy management, and professional photovoltaics. This is all for now. I hope I have caught your attention. For more information, please visit our website.
Okay, welcome back. So I hope the video gave you a good idea of what the system is, what it does. And again, thank you to Marcella, who's watching in today. Great video. Yeah, I think that gives us a really good overview of the system. Again, we're waiting for your questions. So if you've got any, just send them in. In the meantime, I've got lots of questions for you.
Okay.
So we've seen the system there. It was amongst all of the other power engineering systems from Lucas-Nuelle. Is this a part of the, so in the background was the smart grid, for example, parts of the smart grid. Does this fit into the smart grid system at all, or is this more standalone?
This is more a standalone system. In the smart grid, we are using three-phase system because we try to show or teach the distribution of grid. And in the hybrid system, we have a single-phase system. and it's focused on self-consumption. So we are not able to feed power to the grid. We can only use the grid for charging the battery or feed the consumer, or both together. And there's no way to feed it to the grid and use it like in the smart grid. In the smart grid, we are trying to feed a lot of power in the grid, store it, distribute it, monitor it. And in this system, it's not the topic here.
Okay. So yeah, smart grid, again, is a much bigger part, looking at whole countries, cities,
regions.
Yes. Yeah, okay. Okay. We've seen there some new components that a lot of people might not have seen before. There is some components that are used in other areas, but for example, we've got some new solar panels there. They also look quite good. Could you maybe give us an idea? What's the intention of those? Are they there just for good looks, or are they real solar panels, for example?
Yeah, they are ones for the training or for the lab, so you can show how a real PV module looks like. But the idea here is to take the equipment out of the lab, to go outside, to place the solar modules. There are two models where you can fold to transport or to move it better.
With some nice handles on there.
With handles, yes,
yeah.
and you can choose the wiring. It is parallel or serial. And yeah, the idea is to get out of the lab and use it, yeah.
And do the people need tools and extra cable to install those outside, or is there some way of?
No, the total equipment have 4 millimeters
banana plugs, yeah.
Banana plugs and 4 millimeters safety cables. So it's safe to use. You don't need tools. Yeah, just our standard cables.
Standard Lucas-Nuelle plugs. Plug it in. Where you go.
Yeah.
Okay, fantastic. I think the other advantage, which we've seen in the video, is there that you don't actually need the solar panels. Because there's a solar panel emulator as well now.
Of course, in the lab you are using a DC source that emulates the characteristic of a PV field.
Okay, that's I think that's a huge advantage, as we can appreciate living here in Germany with the weather that we have here. You can't really rely on solar panels and the solar energy to be there all of the time. So with the solar emulator and the software that controls the emulator, what was that one called again?
Yeah, it's a solar panel software. With that software, you transmit a characteristic to the DC source, and the DC source reacts and looks like a real PV field. And the inverter thinks or see there's a PV system connected. And
literally, the system has no idea if it's a solar panel or this emulator. It's literally giving out the same characteristics, and you can infinitely adjust that. So you can either have it manually adjusted, or you can even upload program data from your local area, for example.
Yes, a solar profile, so you can emulate a day or week. It's up to you which characteristic profile you are using. Okay,
great, fantastic. So if we have a look at maybe we talk about ILA, Interactive Lab Assistant, the LabSoft course. This is the e-learning component that comes with all Lucas-Nuelle equipment. We spoke about this is probably more for vocational education, so it's quite important to have the theory component there. So would that be covered for the students as well, doing something like this?
So in the course are the whole theory. We have also in some basic courses, but in this course it's included too. All the basic you need to know about a PV system, charge characteristic, battery types, how to program such a system, or how to calculate a project. So which size of PV you need for your consumers, the battery size, that's all included in the course.
Okay, fantastic. We've got a question here. I work in a school as a teacher. Is it too rude to ask about the prices module, for example, for a school in Croatia? So I'll address that. We're both technical guys. I'm from the training side. Fabian's on the product management side. We have zero to do with pricing. But what we do have is we have our sales guys are in the comments here as well. So they'll put their email addresses up in here, and they can contact you directly. So and get in contact with about how much the system costs for you.
Yeah.
Okay. But don't be shy. Send us any other questions that you might have.
And one big benefit of the system is too that you can add the windmill or our small wind mill we have in the in the training system. And you have a small smart grid, microgrid, because you have different sources that you can use to feed your consumers. So PV, wind, grid, but can be also you can say that's a diesel engine or something else.
Okay. With the, for example, with the wind turbine that we have, so we've seen in the video, you can actually have a real wind turbine, or you can have the simulated one with the servo brake of ours. With the small wind turbine, are they creating DC current or AC? What's the, or is it not so simple?
Yeah, the real one is a three-phase, I think. So we have this small wind turbine, and our emulator on the table was synchronous, how it's called, permanent magnet generator. But the controller can handle both and transform it to 12-volt DC to charge the battery.
So that's all taken care of in the is that the solar controller, the inverter, or is
no? There's an additional device because PV and wind is different. So we need two different chargers. One for the solar is included in the inverter, and the wind charger is separate. Okay.
And just a general question about these systems. This one is based off of 12-volt battery, but can you get, say, 24 or 48-volt systems as well?
No, this is a 12-volt DC system. For higher voltages, like 24, you need a different inverter.
Okay.
So the smallest or the smaller systems comes with 12-volt.
Okay. The wind turbine there reminds me of when I was a teacher in Australia, so more than 10 years ago, before I started, when I was actually a customer of Lucas-Nuelle. We bought the system, and to get it running inside and consistently, we put it in front of one of the ventilation ducts in the workshop. So we were able to turn the system to get it operating.
To have some wind.
Wind it actually turned quite fast, so that was good.
Yeah,
Okay, still no questions coming through, so we're either doing a great job of answering them ourselves. Is there anything else that you think people need to know about this system that might be important? I think we've talked about the customers that have this, which type of, I think you also, as part of planning, for people to understand how to plan these systems. So architects, maybe when they're trying to design, what type of power systems are required for houses. It's also...
Yeah, in the most cases, the house is there and you would like to add this system. So you have to look what's there and how I can use the situation to install a system.
Okay.
So that's the main reason.
Okay. And why did you choose a lead acid battery in this case? Everyone's going to lithium nowadays. Is there a reason? Does it really matter what the difference is?
Yeah, once the inverter needs, the inverter must be able to charge this type of battery. And unfortunately, this inverter cannot charge a lithium battery. The second point here is that it's cheaper. The lead acid battery is cheaper, and it can be replaced by the customer. So if it's damaged or it's you cannot use it anymore after some years, you can look if I have this type of battery in my country, and I can easily replace it.
Okay, I think that's a big issue as well. Lithium is still quite expensive. You need battery management systems to control lithium. So it does get quite expensive. Okay, so I think no more questions have come in, so we'll probably leave it at that.
Okay.
What I do want to say is just to say thank you very much for everyone who's joined in over these webinars over the last month now. We've had 4 weeks of these webinars, had over 45 webinars in 5 different languages, and close to 1,000 people from literally all around the world have joined in. So we want to say thank you very much.
Thank you.
And we will continue these in the future, looking at different topics. When new products come out, we'll be able to give you a deeper dive. We'll probably look at doing more live demonstrations with the hardware. If you have any requests for looking at particular systems, let us know, get in contact and say you'd love to have a webinar on a certain system. But we've just got a question come through. So before we sign off, we'll just have a look at this. Hi, I'm a graduate student. Is this system, or does this system allow testing custom controllers, for example, MPPT, voltage and current controllers of the inverter, etc.?
No, unfortunately not, because it's an industrial device and we have no access to the firmware. And so there are no possibilities to use MATLAB or other softwares to design controllers for this system. It's not possible. For this system, but I think some of the other systems that you have in the program could possibly... In the power engineering, not, but we have inverter in the machine area, where you can design and, yes, test own controllers with MATLAB. And that's been completely designed here in-house, that inverter, the frequency converter. So it's completely designed for didactical purposes, so you can have a look at almost any component and control it. And it's also quite an impressive piece of equipment, that one. But this is only possible in the machine sector at the moment. Yeah. Okay, so if that's all of the questions, again, thank you very much. Thank you. Wherever you are around the world, enjoy the rest of your day, and we look forward to seeing you for the next time. Okay. Bye. Bye.